Hey there, everyone. I'm super excited to be part of the AWS Community Day Australia. Interestingly, we're in very, very crazy times at the moment, but I think we'll make this work, and I'm sure we'll have a really, really enjoyable time together today. My name is Olalekan, and I'm going to be talking about continuous delivery for AutoML, also AWS Machine Learning Hero. Just to rush right into it, before we get started, I would love to say that I've always wanted to come to Australia. A colleague of mine at my previous workplace flew to Australia to Sydney for a talk about 2 years ago, 1.5 years ago, and he told me it was about 24-hour flight from Berlin. And I heard that travel restrictions are reducing in Australia and New Zealand at the moment, so hopefully, fingers crossed, at some point in time, I will be able to visit and maybe get whatever we eat in Australia and New Zealand. So I'm going to do a brief introduction of myself. We're going to look through the Amazon AWS machine learning stack. We're going to walk through briefly look through what we already know about machine learning workloads, and then we look at why AutoML and why we should explore AutoML. We then go forth to look at Amazon's AutoML service, Amazon SageMaker Autopilot, and then finally we look at how we build in engineering principles like continuously delivering machine learning models with SageMaker Autopilot with AutoML. So brief introduction, this is me, this is what I look like on a daily basis. I'm a husband, father, and professional data platform tech lead, maybe on work days, and I do all things data, from data engineering to machine learning to computer vision to artificial, all things data. Also, as I already mentioned, AWS Machine Learning Hero, and then I'm obsessed with customer problems. For me, it's not more going into technology for technology's sake, but also more importantly to solving problems. The finally part is that I'm a lover of sport, and I think I was interested in rugby at some point, only that I don't know how to count the points. So shout out to everyone there. Briefly, let's look at the AWS machine learning stack. AWS comes with a broad spectrum of machine learning services or capabilities depending on what you want to explore. For me personally, I like to always start from the AI services, which are pre-trained models and available as APIs where you can pick up and use, and you don't have to think about training your own machine learning model or maintaining all those things. So one of my favorites is Amazon Recognition, which I play with a lot, which has to do with helping with computer vision tasks like identifying objects, images, or doing image classification, object detection, facial analysis, and things that come with that. So you can think of all this at this level of Amazon AI services: Poly, speech and transcribe, comprehend for natural language understanding, translate for language translation, and textract for extracting text in documents or PDFs or images, Kendra, which is really new, which is the search engine that you can plug into any of your services, any of your existing tools, Lex for chatbots. But you can see all these things, and you can see that you don't necessarily have to know anything about machine learning. Just pick it up and then start using available as APIs. And then at the next level, you have machine learning services like across starting with SageMaker and all things around SageMaker, like ground truth for data labeling, the machine learning marketplace, and then SageMaker Studio IDE, and the built-in algorithms from SageMaker. Also, you can also see SageMaker notebooks, experiments for tracking how parameters go around within your machine learning experiments, model tuning, which comes out of the box, and SageMaker Autopilot, which is what we're going to talk about, model hosting, model monitoring to see if your model is how predictions are performing in real time, over time, and see if it's drifting and things like that. And the ML frameworks, this is where a lot of people like to talk about, but for me, I'm not so much interested in this, although it's really good. It's the TensorFlow, the MXNet, and AWS comes with deep learning containers that you don't have to maintain your own container on your own, and they're quite optimized for these frameworks. I think in general, mostly when people talk about the ML machine learning capabilities available on AWS, I would recommend that users or as engineers or fellow people in the community if you're solving the problem, start from the AI services, and then go to the ML services, and then start thinking about the ML. If you want to optimize for an ML framework, or you're interested in doing something really, really custom in TensorFlow, MX, and PyTorch, you can then go with that. But then, thinking about all these capabilities, all these ML capabilities, then we then go further to say, if I have a machine learning problem, let's say I want to be able to predict, classify for my son, I want to help him to differentiate between a cat and a dog, or different animals. I want to know the faces of what I need to do. First, I need to define the business problem, which is, in this case, I want to help my son identify or differentiate between a cat and a dog. And then I frame it into a machine learning problem. So if there's a cat, there's a dog, there are two classes. So that's more of like a classification problem. And then I start thinking about how to collect data and how to integrate the data set. Then the next step is figuring out how to prepare the data, if I need to rescale the images, or if I need to augment the images, so that even if I have quite a handful of images, let's say 100, I want to change the background, resize, put in different shapes so that it can the size can grow. And then maybe if I have some visual exploration and analytics to do, and then visualize it. Feature engineering, starts converting features, extracting tensors and things like that, and then putting it into a model training process. I will evaluate my model depending on the accuracy metric or what I'm evaluating or optimizing for. Then if it meets my business goal, so let's say my business goal is that I want to be able to, on my test data set, I want to be able to classify 90% of images or images across both classes, say cats and dogs, accurately. If it doesn't meet it, I go back and collect more data or do some more data augmentation and things like that. And then if it meets it, then I go ahead to start making predictions. Maybe put an endpoint or deploy it to a mobile app for my son to play with. But you can see that if we look at this process, it's quite tedious, considering the fact that not sure people want to spend time on doing a lot of data preparation, visualization. I never understood visualization. In one of my roles in one of my previous jobs, I always had this back and forth with my manager back then that he prefers to use Bokeh, this Python library that you can use to create visualizations in Jupyter, and really nice, gives some interactive feel. But because I like simplicity and I never really wanted to do anything complex, I just went with Matplotlib. But so you can see that I remember back then having so many back and forth. You can see that these phases in machine learning in themselves are quite tedious and can be cumbersome, and it can be throw-offs for people that don't want to get into it. If you're new into it, as an engineer, I don't want to spend my time doing this. So why AutoML? From a business standpoint, according to Gartner's Magic Quadrant for cloud AI developer services, Gartner predicts that by 2023, 40% of development teams, think about this, 40% of development teams, this is not in one location or another, they're talking about global development teams, will be using automated machine learning services to build models that add AI capabilities to their applications, up from 2% in 2019. This is in a space of, let's say, about 5 years or 4 years, thereabout. We will see 38% jump. This is like an exponential growth. This is an exponential adoption in AutoML, or in adding AI capabilities, not necessarily AutoML, but adding AI capabilities through AutoML into applications by engineers or development teams. This is a great pointer that if 40%, it's in another 4 years, and then in 2020 already, why not let's get started as quickly as possible? And this is one of the things I fell in love when I was at reInvent last year. And I read the ML mission at AWS is to put machine learning in the hands of every developer. What this means is that if you think about the ML capabilities from AWS, the AI services, the ML services, and the deep learning frameworks and things like that, whichever spectrum whichever part favors you along the spectrum, you can decide to pick it up. So, since AWS is already has the mission to put machine learning in the hands of every developer, how do developers actually think? As far as I know, I've always been an engineer at some point, and I still do a lot of engineering. I don't want to spend a lot of time data visualization. I don't want to spend a lot of time doing feature engineering, model training, model evaluation, and things like that. All I want to do is understand the business problem, frame it into an machine learning problem, collect data from my multiple sources, and then feed it into some ML process, and then evaluate if it meets my the desired goal, which brings us to the automated way. So in this way, we blank out feature engineering, data collection, data visualization, model training, model tuning, and evaluation, and things like that, and we simplify the entire process. So we go from business problem, machine learning, framing it into a machine learning problem, data collection, data preparation. The AutoML takes care of the whole entire process, and then we evaluate our business goal. Does it meet our business metric? Does it meet our hypothesis? Our hypothesis validated or not? And then if it does, if they are validated, we go into deploying an endpoint or making predictions and serving customers with machine learning. Enter Amazon SageMaker Autopilot. In this, so what is SageMaker Autopilot? SageMaker Autopilot automatically trains and tunes the best machine learning models for classification or regression based on your data, while allowing you to maintain full control and visibility. So what I've seen so far with regards to when I talk to colleagues, maybe external people around, is that AutoML is a black box, or machine learning itself is a black box, and then you're automating it, which makes it more of a black box. But the idea about the beautiful thing about SageMaker Autopilot is that it gives you visibility, so you can already you can see what's going on there. So you have your raw data in S3. You specify a target column, and then you give it to SageMaker Autopilot. It does automatic model creation, chooses the right algorithm, ranks based on your accuracy metric that you've selected, and picks up the right model for you, and then tunes for you. And for every model that it creates, it writes a Jupyter notebook. It creates a Jupyter notebook saved in S3 for you. And then you have a model leaderboard, so you can pick any model you want. It gives you the top 10, I think top 20 by default, but you can specify the number you want. And if it meets your choice, if you look at it, this is quite similar to the evaluation of the business metric and the phases of machine learning that we have. If it meets your goal, deploy it. And if you have to do some machine learning explainability, or you have to explain a couple of things, you can go ahead, look at the notebooks, download them, tweak, make a few changes, and then you're good to go. Another thing that I've seen so far is that about 70%, between 70 or 80% of AutoML projects don't go beyond their Jupyter notebooks or their workstations. So how do we get this to go beyond our workstation? SageMaker already enables us to do that by a one-liner to deploy a machine learning model. But how can we do this in a repeatable way, so that once we have new data, we can train automatically, we can trigger our training jobs or model training jobs, deploy new models into production, and serve our customers automatically. So now we're looking at merging SageMaker Autopilot, the automated machine learning way, with continuous delivery. So this was a project I was working on for a time being, and it's been quite useful for people that used it. So everything is managed by AWS Step Functions, but it starts with a developer, an engineer in mind, pushing some code or doing something into a GitHub repository. And then from that, the AWS environment takes it up. So it starts from the AWS code build that builds up the necessary Docker containers and build the entire end-to-end process. You can also have a schedule trigger. Let's assume you believe that in your workflow, maybe you have new data on a weekly basis or on a monthly basis, and you want to retrain your model. So once the workflow is triggered, it starts a SageMaker Autopilot training and model evaluation job, and it runs in an automated way. So you don't have to spin off a notebook. All you need to do is specify your data location, specify the target column, and it takes care of that underneath the hood. Once the SageMaker model is finally trained and the model is available, the next step is that it triggers the deployment of a SageMaker endpoint, Once the endpoint is available as well, it triggers the deployment of an AWS Lambda function with an API gateway, a REST endpoint, where you can already start connecting to that and making predictions in real time. So you can imagine, you can think of this as an automated end-to-end process. And with this, you don't have to leave your SageMaker Autopilot projects or evaluations in your notebooks alone. You can then have a repeatable way to deploy autopilot models into production. What this brings is that at the point where this is a fully transparent and automated process, so it's managed by AWS step functions. If something fails, you can see it, you can get notifications and see that something failed or something went wrong. You can also go back into one of the capabilities of SageMaker Autopilot is that you can go back to inspect the notebooks. I think about 2 weeks ago or less than 2 weeks ago, there was a new release of, there was an improvement announced by AWS about SageMaker Autopilot with, I think, 400% increase in speed and about 20% increase in accuracy. So you can see that SageMaker Autopilot is getting better, and AWS is fulfilling its mission, is driving its mission of putting machine learning in the hands of every developer. So the project is available on GitHub. There's a link. You can get this from the slides afterwards. CD for AutoML, Amazon step function, state machine diagram. This is what it looks like. It starts an AutoML job. SageMaker Autopilot is not yet is not have a native integration with step functions, so there's a Lambda function taking care of that. Continually checks. If the job fails, it gets the job failed and sends a notification. If the job succeeds, it saves the best model, creates a model endpoint configuration. If it needs to update the model, it updates the model or creates an endpoint, and then deploys a REST API. All this via step functions, and you don't have to interfere manually with the process. So what's more is that on my free time, I'm working to bring CD for AutoML, which is what I call it, to Amazon CloudFormation. So you can think of it as think of it as part of your deploying as part of your CloudFormation stack. It's quite simple. Declare it as a CloudFormation resource. Specify training data path, the target column, notification email, the workflow name, just for whatever your workflow name, you can give it a name, and the schedule. So if you want your model to be trained every 14 days, every 2 weeks, every 7 days, 30 days, you can specify that, and all this is taken care of underneath the hood for you. What you get back is as the return value in CloudFormation terms is a REST API. So you don't have to think about how the REST API will be deployed. All this is coupling AWS services together, Lambda and API gateway. In the deployed account, this is all you see. So you see that you're deploying a resource, simple CloudFormation resource for the CD for AutoML. In the hosting account, you deploy lots of resources like, let's say, Lambda function, event role, IAM role, and a couple of other resources like that. So you can see that there's isolation, and if you think of this as a team that's providing this kind of service for the entire developers in your company, you're already simplifying their lifestyle, their work for them.